exercise extension 1, that says extension 1, exercise 3.10, further inequations with pronumerals in the denominator. Now, remember the rules with inequalities. When you multiply by a negative, you have to flip the inequality sign, or if you divide by a negative, you've got to flip the inequality sign, or if you take reciprocals of both sides, you've got to flip the inequality sign, whatever. See, the problem with this is my x is the unknown and it's on the denominator. I have no idea if x is positive or negative, the solution. So if x is positive, the inequality sign would stay the same way if I came to solve it. But if x was negative, the inequality sign would have to flip around when I start solving this. The problem is I don't know. I don't know what it is. So x could be positive or negative, but x squared is always what? Positive. So x can be positive or negative. So I cannot solve the equation. So I cannot solve the inequality because you don't know whether you keep the inequality sign the same or you have to turn it around. Like it might be the same for some values of x, and it will be. When x is greater than 0, that inequality sign will stay the same way. But when x is less than 0, the inequality sign has to change. But the problem is we don't know the values of x that are in this solution. All right? So x can be positive or negative, so I cannot solve the inequality. Sometimes we'll have to keep the inequality sign the same way round. Sometimes we'll have to turn it around if we're multiplying or dividing by negatives. We have no idea what the value of x is, so we can't use, well, we're not going to use that method. But we know that x squared is always positive. So, when you're solving equations, whatever, solving inequalities, you can do the same thing to both sides. All right? So what we're going to do, we know that x squared is always positive. So what we're going to do, we are going to multiply both sides by the square of the denominator. By the square of the denominator. So we're going to multiply both sides by x squared. You know how the denominator is x? We're going to multiply both sides by x squared. You know why? Well, what we're trying to do? We've got x on the denominator. I don't want x on the denominator. Once x is on the numerator, this is easy to solve. Once x is on the numerator, I have exercise 3.11. What we were just doing. We go back to 2-unit work. All right, so the 3-unit component of this is just to remove the x from the denominator. Then it becomes 2-unit. All right, so I multiply both sides by x squared, but please do not expand. So this is what I'm doing. Step 1, multiply both sides by the square of the denominator. The denominator is x. I multiply both sides by x squared. What do I have on the left? What's x squared on x? Isn't that x is less than 3x squared? Great. Now, I'm glad I've got this one. You okay with this? You now do not go and divide by x, please. Now when we're solving a quadratic x squared inequality, isn't the rule take everything to the left, factorize, put it equal to 0, sketch the diagram and work it all out. So now this has become like what I was just doing. So, look, some of you might like to, I will take everything to the left, but we're going to have a negative x squared, all right? So now I'm going to take everything over to the left, and I'm going to factorize it. Yes, and I will do that in a minute. That's going to be pathway number 2. So what I want to do, this is what I need to solve. So now I want to solve this, and this becomes 2-unit now. So remember, to solve that, I'm going to put it equal to 0. I'm going to factorize. Do you know what my roots are? 0. Or just be careful, you don't want to mess this second one up. Why lose a mark? Because he couldn't be bothered writing it out properly. Be careful with this one. What is it? I would take the 3x over that way. It's a third. Or you can go negative 3x is negative 1, x is negative 1, over negative 3, x is a third. Whatever way you do it, I probably would have gone 3x is 1, x is 1 on 3. instead of doing the double negatives, but that's okay. Whatever you do, you make sure you do it right, whichever method you've got to use. You don't want to get a negative here when it's a positive. So I go back, like I said, 2 unit methods. Where are my zeros at? My roots, like my x values, 0 and a third. What am I sketching now? This function. So I'm really solving this one. Is that concave up or down, this function? So it's concave down. So I'm going to say that's concave down. And I want to know where this function is less than 0. Remember, greater than 0 equals 0 on the line, less than 0 below the line. What's my solution? X is less than 0. Yes, and x is greater than a third. Now, we are going to do many types of questions. Sorry, there is one thing I should have done at the very, very beginning. This is okay, but very first line, before you start, have a look at what you're trying to solve. What can x not equal? So you must put that first. X cannot equal 0. But that's okay because we have the inequality less than 0. But sometimes this will be less than or equal to 0, and we have to omit one of the equal to's. But we'll do questions like that. All right? So how are you with that? All right. First step, step 1 was to multiply both sides by the square of the denominator. The second step, I didn't write what we were doing, was take everything over to the left, to the left-hand side, and factorize. Now, as someone was saying, why didn't I take it over to the right? And I could, so factorize and then solve, etc., as in 2 unit. So let's say I decided, let's say this is what I had, x is less than 3x squared, and I thought, why am I doing it? Why did I decide to go? Remember, we got this, we multiplied both sides by x squared, we got x is less than 3x squared, and we took everything over to the left. Why don't we take everything over to the right if you don't want negative quadratics? See, a lot of people don't like a negative in front of the x squared. All right? So let's say I decided I don't want a negative in front of the x squared. I'm going to put the 0 here. What do I get? 3x squared what? And then I still solve this with the equal 0, and I get 3x, no I don't, I get x, 3x minus 1, and I get x is 0 or a third, right? Same answer, same points, but am I sketching this time concave up or down? So if I rearranged and put it this way, I have to sketch concave up this time, and I need to see where my function, now, do I look below or above the line? This is written the wrong way around. What I really want to see is the big open mouth facing the function. You know, like that. Open mouth facing function. Pointy bit facing 0. Got it? The function is greater than 0. Or, do you see that? That's what I'm trying to solve. So, I've drawn it. It's concave up. What's my solution? Greater than 0 is above the line. Can you see? So what is the solution? X is? No. It's here. I want greater than 0. X is less than 0. X, that's a third, by the way. X is greater than a third. Now, you know what? If you don't want to... See, when you take everything to the right, you're going to have to deal with this turnaround of inequality. All you've got to do is pull out a negative if there's a negative. So it might be easier to do that. Take it to the left, all right? Inequality with x in the denominator. I don't know if this is going to be positive or negative on the denominator, but what I'm going to do, step 1, is to multiply both sides by what? The square of the denominator. Multiply, this is only for x in the denominator. We've got x plus 3 in the denominator, so multiply both sides by x plus 3 squared. So, I've got 6 over x plus 3 times x plus 3 squared is greater than or equal to 1 times x plus 3 squared. So why do we do this step? It's to eliminate the denominator. So make sure that you cross out the denominator with one of these numerators. And what have I got there? 6 bracket x plus 3 is greater than or equal to x plus 3 all squared. What you do not do is expand x plus 3 squared. Do not start doing that. We're going to do this by factorization. I want everything over to the right. Everything to the left. 6 bracket x plus 3 minus x plus 3 all squared is greater than or equal to 0. What is my common factor? X plus 3 is in common. All good? 6 minus bracket x plus 3. Close bracket. Got it? What's in common? And x plus 3 is in common. I'm left with a 6 minus another x plus 3 in brackets. Expand that second bracket. X plus 3. What is it? 6 minus x minus 3. What's that? 3 minus x. Okay. Great. This is the one that I need you to look at. See, when I look at this up here, well, I can tell, yeah, it is concave down, but it's easier to tell down here. Can you see this is concave down? I'll tell you how you know this is concave down. When you start expanding this, you just need to multiply your two x terms to see if it's concave up or down. When I do x times minus x, it's negative x squared. This is concave down. So now I sketch it. I look at that. I know that that's concave down. Look, I've got x times 3 is 3x minus x squared plus 9 minus 3x. Doesn't matter about the x's. It's the x squared, the coefficient of the x squared that determines if it's concave up or down. It is definitely concave down. How do I know? Because x times negative x is negative x squared. So I can sketch this parabola. So the important thing here, girls, is not to expand this. I don't want you expanding this and this, forming a new quadratic and factorizing it. Yeah, in this case it would be easy, but there are cases and questions where you're going to find it impossible to do. And there are ones where you'll get cubics, which you don't know how to factorize. All right, so we'll do those ones tomorrow. Yes. Right, so concave up or down? Oh, so remember we solve and put it equal to 0, right? But this is the one I need to be sketching. I put it equal to 0, and what do I get? X is negative 3 or 3. So I put those two on my number line, make sure the smaller one goes first, because otherwise, if it lies on the outside regions, you're going to get it wrong. All right, is it concave up or down? Down. So you put that equal to 0, so we really want to solve this, but this is what we're going to be sketching. Down, negative 3 and 3, and I need it to be greater than or equal to 0. So greater than 0 above the line, equals 0 on the line, below 0 is below the line. Need greater than or equal to 0 here. You can even colour it in. It's there. So my solution is x lies between negative 3 and positive 3. All right, you know what we've never done is tested some values. Let's just have a quick look. Let's choose a value between negative 3 and 3, just in our head. 0. Let's go to the original. I'm just checking my answer because I haven't done that yet. All right, you know, we're going to try x is 0. What do you get? 6 over what? 6 over 3. Yay, true. 2 is bigger than 1. Let's try something, so we know that's true. Let's try something that we know is not true. Let's try negative 4. That should not work. So here's the original question. If I put x is negative 4, what do I get? 6 over negative 1. Is that true? And let's try something on the other side that, do you understand that x lies between negative 3 and 3? So something like x is 4 would not be an answer. 6 over 7. See how they don't work? All good? Okay. Same example as the textbook, but we're using our method. So what is our first step? Multiply both sides by the square of the denominator, which is y squared. Why do we do it? To eliminate the denominator. Why else do we do it? Because we don't know if y is positive or negative, But if we multiply by y squared, that's multiplying both sides by something positive. The inequality sign doesn't have to change. We do not go expanding stuff. What should I do with this y squared and y? Cancel. And I've got y squared minus 6 times y. I'm going to put the y out the front. Is that okay? Is less than or equal to y squared. Are we good? Why do we do this? We need to get rid of the denominator. So we've gotten rid of the denominator. There's no issues about the inequality sign. It's correct because it's y squared. Take everything over to the left. Oh, what am I doing? One sec. Look, if you wanted, you could expand this. You'd get y cubed minus 6y minus y squared. But what do you think? Looking at it now, what is the common factor? Y is in common. So go y squared minus 6 minus what? Y. Good. And y bracket y squared minus y minus 6. Do you know why I wrote it like that? Because, you know, it's a quadratic and we want the x squared term and then the x term and then the constant. And what does that help you do? Factorize. We're hoping it's going to be y minus 3. I'm thinking y plus 2. Yeah? Y squared plus 2y minus 3y. Yep. Okay, now. Oh, I have to show you how to sketch these. Now, this is a polynomial. This is a cubic. Because y times y times y is y cubed. So this is not a quadratic. So we have to learn how to sketch these now. So this is what we've got. Where are the zeros? So of course we solve it equal to 0. Sorry, I shouldn't put that line there. Put it equal to 0. Don't worry, we're going to do these again tomorrow. All right, we'll do more of these ones tomorrow. And then we get y is, what are my solutions? 0, 3, and negative 2. So here are my solutions, negative 2, 0, and 3. I mean, it's better to learn how to sketch it. Otherwise, you've got to test 1, 2, 3, 4 regions, which we're not going to do. Now, it's a cubic. Cubics look like this, or like this. I know you've seen cubics look like this, or this, but this type of cubic is y equals x cubed. We're not going to get that type. And we're learning about this in the next chapter, functions. This cubic is y equals negative x cubed. That's what it looks like. But you won't be using these. You just have to know your cubics look like this or like that. You know how this is more natural to draw? This is the positive cubic. In other words, this is the cubic with a positive y cubed term. And this is the cubic with a negative y cubed term. So it actually looks like this. Okay? And so this looks like this. So you tell me where we're trying to solve. Where is it below the line? Above the line, equal, below. Where is it below the line?
Less than negative.
Be careful. Actually, I need to come back up here. What? Y cannot equal what?
0.
Good. So x is less than or equal to negative 2, but x lies between 0 and 3, but x, sorry, it's y. Y, I'm not allowed to put y, and the equation, the question has less than or equal to 1. I'm not allowed to put y equal to 0. So I've got to go 0, y lies between 0 and 3. But y can equal 3, but it can't equal 0. Do you get that? I would have put less than or equal to, but y can't equal 0. Now tomorrow we'll be doing more of these.